Okay, I want to talk a little bit about compositions and domain. This is going to be a kind of a complicated topic, and with these rational functions, you get a lot of things to think about. First off, remember that if I have a fraction times another fraction, I can just multiply straight across. That's 3/8. If I have a fraction divided by a fraction, I would rewrite it as multiplication by keep the first, change this from division to multiplication, and flip the second. So that makes 18/20. Of course, 18/20 can be simplified down to 9/10. Okay, so those are some basic things to keep in mind as you're going. So let's start with f of g. So basically, this notation means that I'm sticking g of x into f of x. So in other words, where I have the inputs here, I'm going to stick in, so I'm sticking here and here, the entire function g of x. So it's going in there, it's also going in there. So what ends up happening in that situation? Well, first off, I get minus 6 over x over minus 6 over x minus 3. Well, that's pretty disgusting, and I'm sure you're going to want to simplify that. Easiest way to simplify it is to multiply the top and the bottom by the same thing. If you multiply by x here, then you get some simplification, and this cleans up quite a bit. So minus 6 over x times x, that's going to be negative 6 on the top. On the bottom, the x needs to distribute. So I'm going to go here, and it's also going to go here. So I'm going to have minus 6 again, but I'm going to have minus 3x. Now, if I wanted to, I could simplify. There's a common factor here of negative 3. So I'll take out negative 3 from the top. I'll take out negative 3 from the bottom. That can be simplified, and I end up with 2 over 2 plus x. Now, there's two things to think about in terms of the domain here. Number one, there's the composite function, which is saying that I have a denominator of 2 plus x, so x had better not be equal to negative 2. But also, this was my initial function, and my initial function was negative 6 divided by x. So I also should not have x is 0, because then that would break the initial function. Even though this is cleaned up to make it look like 0 would be an okay input, it's not an okay input because it's f of g of x. And f of g of x, although we can simplify it algebraically, g of x is still a thing. G of 0 is a domain problem. Okay, so there's two considerations. That's the big thing for these domain problems, which is the domain of the original and the domain of the composite. Notice that the domain of the outer one is not an issue necessarily, right? This 3 here would be the problem for f of x, but 3 is not a problem because the question is, how do I get 3 as an output for g of x? And the answer to that is when x is negative 2. So that's where this comes from. Okay. Let's take a look at another one here, maybe one where they are nested into each other. So let's do g of g. I'm going to go ahead and erase a bunch of stuff here and give myself some more space. So I don't know if it's more confusing or less confusing to be sticking a function into itself, but it's the same concept. We're going to take g of x. Let's do this last one. We want to put g of x into itself. So we're going to put something in there, and the thing we're putting in there is minus 6 over x. So in other words, you have minus 6 over minus 6 over x. This is a great situation to use division. This is minus 6 divided by negative 6 over x. So in other words, rewrite negative 6 over 1 times x over negative 6. Cancel that out. That simplifies to x. Does this have any domain limitations? No, this is all real numbers. But don't forget, you have to consider the original function. The original function, that this one, is g of x, and so that means that it's not all real numbers. The domain is that x should not be equal to 0, because that's the domain problem for g of x. Okay, so I hope that helps clarify a little bit composite functions, sticking one function into another, getting a domain. Let's do one that's a little harder, just to be crazy. Let's say g of x equals the square root of 2x plus 1, and h of x equals 1 over 3 plus x. So we want to find g of h of x. That's g of h of x. And we want to talk about the domain of this composite function. You can go ahead and pause the video and see what you can do on your own, and I will press forward here. Okay, so I'm putting h of x, this, into my spot here. So in other words, g of h of x is equal to square root of 2, big parentheses, and where I had x, now I'm putting in the function h of x. So in other words, now I have the square root of 2 over 3 plus x plus 1. This is probably way harder than you'd ever be asked to do. Okay, second part, domain. There's two things I need to consider. I'll start with the easy one. The domain of the original interior function, the thing that's getting plugged in, is clearly x should not be -3. That keeps my domain, my denominator, from being 0. This is the part that's harder. I need to answer the question, when does 2 over 3 plus x plus 1, when is that greater than or equal to 0? Because remember that the square root should not be of a negative number, so you can say that positively or negatively. You can say not less than, or you can say greater than or equal to. So I'm going to use the greater than or equal to. 2 over 3 plus x is greater than or equal to -1. Now this is a little bit tricky here, because if I multiply both sides by 3 plus x, there's really two possibilities. One is that, and again, I don't, this may be going deeper than you need to. Feel free to turn off the video. If 3 plus x is greater than 0, so in other words, if x is greater than -3, then I'm multiplying by a positive number. So in other words, this 2 is going to be greater than or equal to -3 minus x. So in other words, 5 greater than -x. So, oof, man, -x is less than or equal to 5. And so x is greater than or equal to -5. So this is one condition that works. And I can check it by putting numbers that are bigger than or equal to -5 to make sure it works. If x is -5, then 3 plus -5 is -2, and 2 divided by -2 is -1, and -1 plus 1 is 0. So yes, that would work just fine. And things that are greater than that, like, let's say 10, 2 over 3 plus 10, this is a positive number, that's going to be a positive number, so I can take the square root of a positive number, no problem. So this is one of my parts of my domain. So keep in mind, I got to get this thing involved. But I should also consider this other situation, which is it's possible that 3 plus x could be less than 0. So I need to examine that side next. Okay, so we got 3 plus x is less than 0. So then in other words, this is the case where x is less than -3. Well, when I multiply then, it'll be 2 is less than -3 plus x. And that's because when I multiply by a negative number, this sign shifts. So in other words, 2 is less than -3 minus x. So plus 3, that's 5, is less than -x. And so when we multiply by -1, we still end up with, well, we got 5 is greater than or equal to, sorry, -5 is greater than or equal to x. That's actually x is less than or equal to -5. So that's a little weird because that's basically the other side of this coin. Now, is it possible for things less than -5 to work? Let's find out. Let's try -10. If this is -10, -10 plus 3 is -7. 2 divided by -7. So that's okay. So kind of seems like it would be all, like there's no problem with 2 over 3 plus x plus 1. This is the kind of situation where I would like to look at the picture of 2 over 3 plus x plus 1. And to do that, my go-to is Desmos. So I'm just going to go over here to Desmos. Two over 3 plus x, and then I'm adding 1. And the question is, can I get negative numbers? And the answer is yes. Where are the negative numbers? Well, there's -5, right? This is this special point that makes the interior 0. So it looks like from -5 to -3, we have a little bit of a problem. And this kind of reinforces in a way that the strategy of, when we're solving this, you choose your kind of critical points. -5 and -3 are your critical points. And this works, and this works, and this part here does not work. My check, remember when I looked at -5, x is greater than or equal to -5, I looked at -5 and then I looked at 10. Well, both of those things work. It's this little section right here that doesn't work. So really drives home the point that a visual representation can be a helpful way of seeing that as you're solving the problem. Okay, like I said, that was way harder than you would actually be asked to do. But the domain of that function, then, let's go back to the whiteboard here. So we got our function. And we came up with 2 intervals from -infinity up to -5, including -5, because that is the input that gives us 0, and the square root of 0 is 0, so that's fine. And then from -3 to infinity is another interval. So now I want the union of those two things. So that's the domain of that crazy example. All right. Hope that last part didn't confuse you. Just wanted to go a little bit deeper on it. Talk to you later.